Deep within the high-performance cooling systems of the natural world, the honeybee operates as a living thermal regulator. While we use air conditioners to stay cool, a colony of bees uses a collective mechanical strategy to keep their hive at a perfect, steady temperature. The machine facts of the hive reveal that when the interior gets too hot, the bees transform into a massive exhaust fan. They line up at the entrance and beat their wings in perfect synchronization, creating a powerful draft that pulls hot air out and cool air in. To enhance this cooling effect, the bees employ a form of evaporative cooling. They spread thin films of water over the wax cells of the hive. As the wing-driven airflow passes over the water, it evaporates, dropping the temperature of the entire biological factory. This engineering solution is critical because the hive's software, the developing larvae, cannot survive if the heat fluctuates. The bees must maintain a consistent operating temperature of 95 degrees, regardless of how blistering the sun is on the outside of the box. Psychological facts suggest that bees possess a swarm intelligence that allows them to solve complex problems without a central leader. Each bee acts as a single sensor, detecting heat spikes and responding instantly to keep the collective machine running smoothly. Humans must treat and care for the flowering fuel stations that keep these pollinators moving. Pesticides and habitat loss act like sand in the gears, disrupting their ability to navigate and communicate. Stewardship of the garden is vital for the global economy. The history of the honeybee is a record of structural perfection. The hexagonal shape of their wax cells is the most mathematically efficient design in nature. It provides the maximum amount of storage space using the minimum amount of building material or wax. Nature facts show that a single bee can visit up to 5,000 flowers in one day. This high-frequency reloading process is what powers the entire hive. They're the primary engineers of our food system, responsible for 1 out of every 3 bites of food that we eat. Caring for the honeybee is a form of global maintenance. By providing pollinator corridors, we ensure that these tiny machines have the energy they need to travel between habitats. If the bees stall, the agricultural output of the entire planet begins to fail. The machine facts of their flight show that bees flap their wings 200 times per second. This high-frequency vibration creates a positive electrical charge on their bodies. When they land on a flower, the negatively charged pollen literally jumps onto their fur. Microscopic view of pollen grains sticking to a bee's statically charged fur. Engineering comparisons often liken a hive to a superorganism. It functions like a single animal with thousands of replaceable parts. This redundancy ensures that if one component fails, the rest of the machine can continue to function and support the colony. Every jar of honey is a lesson in the power of incremental work. To produce just 1 pound of honey, the colony must fly over 55,000 miles, more than twice the circumference of the Earth. It is a testament to what can be achieved through small, repeated actions. Every garden is a laboratory of biological production. By respecting the quiet hum of these winged engineers, we recognize the labor that goes into every fruit and vegetable. It is a partnership between the soil, the sun, and the tiny machines that tie them together. Let the honeybee remind you of the value of contribution. Even the smallest individual can play a vital role in a massive system. In your own life, your daily efforts, however small they seem, are the fanning wings that keep your own community thriving and cool. Take care of the buzzing hardware of our world. As we look toward the food security goals of 2026, protecting these aerial engineers is a top priority. Respect the flowers and protect the hive, so the rhythm of the garden may continue to beat for centuries to come.